Hi guys, so welcome to my second video on important functions in my pre-calculus function series. In this video guys, I'm going to be covering polynomials and rational functions. Okay, so without further ado, let's get going. A function is a polynomial if it can be described like so. Okay, so it can be described as an xn plus a to the n minus 1 times x to the n minus 1 plus dot 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 a to the 1 x plus a0. Okay, so what do we know? N has to be greater than 0, and n has to be enclosed in Z. Okay, so what does n have to be enclosed in Z mean? So n has to be enclosed in Z means that n is an integer, and a0 are coefficients that are enclosed in R, so in real numbers, so they could be any number. So, okay, so what do we know about, what can we generalize about polynomials? Well, we could say that the domain of a polynomial is between minus infinity to infinity. As for the range, it'll depend on the polynomial. We'd have to look at the polynomial in order to understand the range, okay? So that's it, guys. The other property about polynomials is the degree, okay? So the degree of the polynomial is the value of the n, is the value of the highest n, okay? That doesn't have, whose coefficient is not 0, okay? So we'll see some examples and that'll become clear to you, okay? So let's go look at those examples. So here are the examples. So the coefficient here is m. M is enclosed in R, okay? And mx plus b. So this is basically a line, and it is a polynomial, okay? So it's a polynomial of degree 1. If degree 1, if m is not equal to 0, okay? The polynomial is degree 1 if m is not equal to 0. And the domain and range of this polynomial is, as we know, so the domain is between minus infinity to infinity. We've seen this kind of example many times, and the range is minus infinity to infinity as well. Okay, so the degree of this polynomial, what do you think? What's the highest value of n with the non-zero coefficient? It's 2, right? The 4 is non-zero, and x to the squared has 2 as its x to the squared is higher than x to the 1. So the degree of this polynomial is 2. So we know that the domain from our from what we said above, that is between minus infinity to infinity. The range, we'll have to graph this polynomial, and later we're going to see more tools to help us figure out the range, but we could graph this, we need to graph this polynomial to figure out the range, or we'd have to do a little bit of algebra to figure out the range. Maybe that could be a problem that I'll be doing in the problem sets that come after the theory. And here, what is the degree? 3, right? Because of the 2. So degree is 3, and we know the domain is the same. The range, we'd have to study this polynomial in order to figure it out. Okay, so that's it, guys. So that is the intro and intro to polynomials. Yeah, and the domain of the polynomials is always between minus infinity to infinity. Okay. Now let's go look at rational functions. Okay, what is a rational function? A rational function is a function that is a ratio of two polynomials. Okay, the domain is all x except where q of x is equal to 0. Okay, so that's it, guys. Now let's look at some examples of polynomials. So we of rational functions, excuse me. So this is x squared plus 3x plus 1, which is a polynomial, and here it's 2x minus 1. That is also a polynomial. So what is the domain? The domain is all x except when um, x is equal to a half, right? Because when x is equal to a half, 2 times a half is 1, and 1 minus 1 is 0. So the domain is between minus infinity, excluding a half, union half to the infinity. That's it, guys. Okay? So now let's look at another polynomial. X to the 4 plus 3x squared plus x over x squared plus 1. What do we think the domain of this is? It's minus infinity to infinity, right? Why can I do minus infinity to infinity? Well, because there is no value where x squared plus 1 is going to be equal to 0, right? Because x squared is always going to be a positive number, and a positive number plus a positive number is not 0, right? So for that reason, um, the domain is minus infinity to infinity. Okay, so basically that's it, guys. So that's a polynomial function, and this is a rational function. These are two types of functions we're going to see in the study of calculus. And let's go look at other functions that we're going to see. Okay. Other functions that we're going to see are, other functions are algebraic functions, okay? An algebraic function is basically the addition, subtraction, multiplication, or division of two polynomials, okay? So if I did x squared plus 3x plus 1, so let's give you an example of an addition. So if I did x squared plus 2x, this is an algebraic function. It's a polynomial, but it's also an algebraic function because I have a polynomial x squared plus 2x. Okay, so that's an algebraic function, and a subtraction is same thing, x squared minus x. A multiplication is x squared plus 1 times 2x plus 1. Okay, so these are two polynomials that we're multiplying, and the division is just rational functions, right? Rational functions are algebraic functions, and just a special case of algebraic functions. That's it, guys. So let's move on. Okay, guys, the last thing I want to touch on in my important functions for calculus series is a property called even and odd functions. Okay, even functions are functions that respect this property. F of x is equal to f of minus x, and odd functions are functions that respect the property f of x is equal to minus f of minus x. Okay, so let's do this. Okay, so so let's start with x cubed. Okay, you see that x cubed is an odd function. Why is it an odd function? Because if I plug in a number here, for example, minus 1, okay, f of minus 1 is going to be minus 1, right? Now, if I followed this property, and if I plugged in 1 here, because minus minus 1 is 1, so if I plugged in f, okay, so let me start with f of minus 1. F of minus 1 is equal to minus 1 here, right? Now, if I plugged in f of 1, which is minus minus 1, it is going to equal 1. Okay, but for this property to hold, f of 1 must equal minus f of minus 1, which it does, right? Because f of minus 1, as we see, is minus 1, and minus f of minus 1 is 1. So f of 1 is 1 and minus f of minus 1 is 1. So for this reason, we can see that it is an odd function, right? And you could see that if you plug in any value of x for x to the cubed, you're going to see that it is an odd function, okay? And furthermore, we could generalize it to say that for any power function, so if you remember, a power function is a function in the form of x to the a, okay? F of x is equal to x to the a. So if, let me clean that up. F of x is equal to x to the a. Okay, so for any value of a odd and greater than 0, this property holds. Okay, this property holds, and so all power functions where a is odd are odd functions. Okay, all right. So now let's look at even functions. Okay, an example of an even function is f of x is equal to x squared. This is easy to see. We're very familiar with this function. We've seen it everywhere. F of minus 2 we know is equal to f of 2, right? Because whatever value I put in, if I put the negative of that value, I'm going to get the same thing because I'm squaring it. The square does not the square returns the same value whether the x is negative or positive, right? So for that reason, we can see that x squared is an even function, okay? But furthermore, for f of x, for all power functions, if a is even, f of x is an even function, okay? So this is just two examples of even functions. There are many more that I'm going to cover in the problem sets that follow, but I just wanted to introduce you to the property. So the property, guys, is simple. A function is even when f of x is equal to f of minus x, and a function is odd when f of x is equal to minus f minus x. And remember, guys, a function could be not even and not odd, okay? There are functions that are not even and not odd. So, for example, this function, this polynomial function, it's not even and it's not odd. If I plug x squared plus x, okay? So let's do f of 2. Okay, so this is f of x, okay? X squared plus x. Now, what's f of 2? F of 2 is equal to 2 squared, which 2 squared plus 2, which is equal to 6, right? And let's do f of minus 2. This is equal to minus 2 squared minus 2, which is equal to 2, right? So you see f of x is not equal to f of minus x, and f of x is not equal to minus f of minus x. So this function is neither odd or even. So a function could be even and odd, or it could be neither. Okay, so we're going to see more problems like this, and yeah, we'll become more comfortable with the idea. Okay, so once again, guys, thanks for listening to my video. My next video is going to be on trigonometry. It's just going to be an intro to trigonometry and how what things you need to be familiar with when we start studying calculus, okay? And that's going to be my last theory video for a while, and I'm going to do a lot more problems, and then we'll come back to theory. So I'll alternate between theory and problems so it doesn't get too boring. Okay? All right. Thank you, guys. Thanks for listening. Have a good one.